Hello everyone. Today topic is equalization and diversity. Myself, Mr. A. Karthik, Assistant Professor, Department of Electronics and Communication Engineering, Institute of Aeronautical Engineering, Hyderabad. Okay, today we discuss mainly about the equalization and also diversity. With the help of these topics, the student can learn what is the process of equalization, what are the diversity schemes. Okay, with the help of these two equalization and diversity schemes, we can reduce the distortion of the received signal. The student can learn. Okay, actually in the first module and second module we discussed interference. Okay, and also second module we discussed the propagation. The propagation is nothing but the small scale area and also large scale area, both large and also small scale area. Okay, with that we're having some disadvantages. What are the disadvantages? We can overcome by these module, that is the equalization and diversity. Okay, the student can learn what are the process of equalization and diversity schemes. The first one, what are the properties of the mobile radio channels? Okay, here we having the two types. One is a multipath fading and also second is a Doppler spread. Okay, why we go for the multipath fading? Okay, it occurs the time dispersion and also intersymbol interference. And also coming to second one, Doppler spread. Okay, here having the properties of dynamical function. Okay, these two effects are strong negative impact on the bit error rate and also any modulation. Okay, these two occurs the what are having the multipath fading and also Doppler spread. It occurs the bit error rate of any modulation. We having the analog modulation and also digital modulation. Okay, and also we have the different schemes in the modulation also. Okay, the mobile communication system requires signal processing techniques that improve the link performance in hostile mobile radio environments. Okay, we are using the equalization process and also diversity process. Mainly, we can improve the link performance of the mobile radio environments. Okay, that is one advantage of the equalization and also diversity. Okay, the popular techniques. Here we are having the three types of popular techniques for overcome the disadvantage of the mobile propagation. The first one is equalization, second is diversity, and third one is channel coding. Okay, these are the three techniques for the equalization and diversity. Okay, first one, equalization. What the necessary of equalization? Okay, it mainly compensates the intersymbol interference. Whatever having the interference from the intersymbol interference, we can overcome by the equalization. Okay, in this one we can the process to equalize the signal. Okay, then we can compensate the intersymbol interference. And second one is a diversity. Okay, here we having the different types of diversity. Those also we can discuss. What are the different types of equalization also we'll discuss in this module. Okay, diversity is a compensate for channel fading. Okay, in the previous modules we discussed what is a fading. That is nothing but some gradual changes in the signal experience. Okay, there we having the two types of fading also, slow fading and also fast fading. Slow fading and also fast fading. Okay, with the use of these diversity techniques, we can overcome that fading also. And coming to third one, channel coding. In the previous semester also we discussed what is analog modulation schemes. What are the digital modulation schemes? There we are using the different types of channel codings. Okay, with the help of the channel coding, we can detect or correct the errors. Okay, these are the three types of popular techniques for the equalization and diversity. Mainly, those are the independent also. We can use these techniques. Okay, sometimes we can go with the only equalization. Sometimes we can go with the only diversity. Sometimes we can go with the equalization, diversity, and also channel coding. With the help of these three techniques, we can improve the signal performance. That is a link performance. Okay, here you can see what is a transmitted signal. That is a SFT. We can assume the channel model. That is HFT equal to sigma alpha k tau t minus tau k. Okay, and received signal RFT equal to SFT into HFT. That is a transmitted signal and also channel model. We can go with the received signal. This is some examples of the transmitted signal and also received signal. That is a channel mode. Okay, nothing but communication. Okay, if the modulation bandwidth exceeds the coherence bandwidth of the radio channel, the intersymbol interference occurs. The modulation pulses are also spread in time. Okay, actually we go with the equalization. What is equalization? It mainly compensates the intersymbol interference. Okay, here the intersymbol interference occurs. The modulation pulses in the spread in time. That is the one problem in the intersymbol interference. It exceeds the coherence bandwidth also. Okay, the mainly it compensate the the equalization process compensate the intersymbol interference what are the created by the multipath within the time dispersive channels. Okay, the time dispersive channels what are having the multipath creating in the intersymbol interference we can compensate by the equalization. And also the receiver compensate for the average range of expected channel amplitude and the delay characteristics. Okay, we are having the time delay and also we having the some delay path. Okay, those are the characteristics. We can go with the equalization. Mainly the equalizer must be adaptive since the channel is generally known as unknown and also time varying. Okay, whatever having the equalizer in that adaptive, okay, the channel is known as the unknown and also time varying. Okay, these are the equalization. Okay, mainly it go with the intersymbol interference. It compensating the whatever having created by the multipath, then we can go with the equalization. Okay, and also it can reduce the depth and duration of the fades experience. What is the fades experience means we're having the slow fade and also fast fade, nothing but a large scale and also small scale. In that we're having the slow fade and also fast fade. Whatever fades experience the receiver, that is in the narrow band channel, and also without increasing the transfer power we can increasing the link performance. Okay, and also it can employ the both station and also mobile receivers. Okay, here we having the different types of diversity techniques. One is antenna polarization diversity and frequency diversity. The third one is time diversity. These are the types of diversities we can use the link improving the link performance. Actually, we can also improve the link performance by the increasing the transmitted power or bandwidth. But without transmitted power increasing and also bandwidth, we can use the these diverse techniques. We can increasing the signal link performance. Okay, next one is channel coding. Why we go for the channel coding means it is to improve the mobile communication link performance by adding the redundant bits in the transmitted message signal. In the whatever having the transmitted message signal, we can add the redundant bits. We can add the redundant bits. Then we can improve the link performance of the particular communication of the radio channel. Okay, we in this one we can use the transmitter and also channel coder maps or digital message sequence into the another specific code sequence, and also it containing the greater number of bits originally contained in the message. Actually, the message having the some bits but are having the zeros and ones. We can using the greater number if it is a add parity, if it is a even parity, we can add the redundant bits. Then we can go with the particular content message signal to the particular communication. And also whatever using the code message then it modulated for the transmission in the wireless communication. It is coding and is considered to be post detection technique. The mainly we are having the two types of channel codes. One is black codes and also conversion codes. Okay, these are the two types of channel codes we can discuss in the next slides. Whatever what is equalization, what are the different types of equalization, and next diversity, what are the different types of diversity, and also channel, what is the channel coding, what are the different types of channel coding also we will discuss in the next classes. Okay, now this is a channel coding. Why we go with the three techniques? One is equalization, diversity, and also channel coding. Mainly with the help of these three techniques, we can improve the link performance of the radio communication radio channel. Okay, they can increasing the performance of the particular communication. And we can see the equalization and also diversity and channel coding is mainly improve the link performance, and we can minimize the bit error rate. But approach costly, some having the cost effective and complexity. And also these techniques we can use in the practical wireless communication system also. What are having the equalization, diversity, and also channel coding. Okay, the first one is equalization. In that we can see the what are the fundamentals of equalization. Intersymbol interference, it mainly caused by the multipath propagation with nothing but a time dispersion, that is the spread in time in the particular bandwidth, and also causes it bit error rates at the receiver, and major obstacle high speed data transmission over the radio channel. These are the three causes for the intersymbol interference occurs. Okay, the first one is by multipath propagation. Propagation nothing but the transmission of the signal. Transmission of the signal from transmitter to receiver. Okay, it is traveling from the transmitter to receiver. It what will happen whenever travel from the transmitter to receiver, it will be having the different obstacles. It touches the signal and also it touches the another building. The finally it reaches the receiver section. Here, what will happen? The multipath propagation. You're having the multipath propagation. Okay, it go with the what will happen? It go with the time dispersion also. It go with the time dispersion. That is the one cause. And second one is we can have the bit error rates also receiver. We can overcome the channel coding and the high speed of data transmission over the radio channel. It is a major obstacles. Whenever traveling from the signal from transmitter to receiver, we're having the different types of obstacles, and also we have different types of mechanisms: reflection, diffraction, and scattering. That is a propagation mechanism. The based on the propagation mechanism also, it having the some intersymbol interference. Coming to it, equalization, it is a technique used to combat the intersymbol interference. Nothing but is compensating, and also it can having the signal processing operation that minimize the intersymbol interference. Usually track varying the channel adaptively. First one, what is the equalization? What is the operating modes in the equalization? But we know the what is the next set of equalization means. It mainly compensate the intersymbol interference. Okay, whenever we go with the operating modes of the equalization, the first one is a training section, and this is a training section. That is the first stage. We have the tracking section also second stage. But coming to first stage, what will happen? Here we can go with some training sequence. That is a fixed length. We know it. What is the sequence? Also we know it. That's sent by the transmitter. From the transmitter to receiver, this is a fixed length. We know it. What are the bits? 3 bits or 4 bits or 8 bit or 16 bit. We know it. Okay. Then the receiver equalizer may be average to proper setting. That is in the first stage. And also whatever having the known training sequence, we can permit to an equalizer at the receiver. It acquires the mainly proper filter coefficient in the worst possible channel conditions. Okay, we are having your FIR filter and also IARE filter. What is a FIR filter? What is IARE filter? Also we discuss in the next classes. What is the need of FIR filter in this coefficient condition? What is IARE filter condition? Also we can discuss in the next slides. Then you can understand what are the proper filter coefficient for this particular training section of the equalizer. The time span of the over equalizer convergence is a function of the here mainly go with some input signal and convergence and output signal. Okay, input signal convergence to the output signal. In between, what will happen? We have the block diagram. Then you can see the first one is we can use the equalizer algorithm. Second one is equalizer structure, and third one is the rate of change of the multipath radio channel. Okay, these are the convergence from the equalization. Coming to second stage, the first one is a training session, and second stage is the tracking section. Okay, here the data whatever having the received from the training section, we can go with the adaptive algorithm. This is the equalizer tracks of the channel, changing the some adjustment of the filter coefficient of the particular characteristics over a time. Okay, in this digital communication system, the data is segmented into short time blocks. We can use the different modulation techniques for CDMA, TDMA, like that. Here we can using the TDMA wireless systems are particularly well suited for the equalizers. This is a time division multiplexing wireless system is suited for the equalization. Here mainly we are having the two types of stages. One is a training stage and second one is a tracking stage. What will happen in the training stage means here the fixed length of the training sequence is the go with the from the transmitter to receiver. At the end of the tracking session, we will get the original message signal from the tracking session. In between, we can using the some adaptive algorithm. We can see the diagram, then you can understand easily. Here we having the training and also tracking. This is a training. Okay, this one is a tracking. You can see here this is a message signal. This is a message signal. From that it can travel from the modulator and we can use the transmitter in the radio channel. the radio frequency front end and immediate frequency stage, detector, matched filter. And this one is a convoluted. This is a function of the convolution. It is a function of convolution here, including the message signal and also modulated signal. The modulated signal it can transmitted through the transmitter to radio channel, and also it can find out the some coefficient using the detector matched filter. Then whatever having the output from the training section, we can give into the adaptive equalizer. Here we can including the noise. Here we can add the noise. Here we are adding the noise to the particular whatever having the detector matched filter, and also those two will be given to the adaptive equalizer. Here it equalize the tracks. Okay, in this one it equalize the tracks. What we have to write, y of t equal to, we can write y of t equal to, what is that, x of t and also convolution of the f of t plus noise nb of t. This is a y of t. You can see here this is a message signal. Okay, the what is the received signal, y of t equal to x of t and convolution of f of t and also noise. Okay, then we can all the tracks is given to the adaptive equalizer. Here we can compare with the previous signal. We can compare the previous signal. If any error comes, again it equalizes the tracks. Okay, if any errors, it equalizes the tracks. Then the original message signal from the decision maker, it goes as a output. Okay, this is in the adaptive equalization. This is a equalization process in the communication system. Okay, like this we can find out the particular this one. Okay, and also the base whatever having the equalizer can be implemented at a baseband, and also we can use the immediate frequency in a receiver. Okay, we can use the adaptive equalizer algorithm. Here we can use the equalization of adaptive algorithm. This is the equation, y of t equal to x of t into convolution of the f of t plus nb of t. And also we can use this one. This is the first equation. What is the d cap of t? Okay, this is a d cap of t equal to, we can write x of t into f of t, and also we can use the equalization, that is the adaptive equalization. We can go with the adaptive equalization plus we can having the noise and also equalization. Then what is the equalization equal to? That is a sigma k into k ck delta d minus nts. This is the h equivalent equal to. Then while we're having the intersymbol interference, we can write as a h equivalent of t convolution of the f of t equal to delta of t. Okay, this is some equation from the particular d of t. Okay, like this we can find out the equalization of the intersymbol interference. Here we can use the two types of stages. One is first stage is a training stage, and second one is a tracking stage. Like that we can find out. Okay, next one is a survey of equalizations. Okay, what are the different categories in the equalization techniques? Okay, equalization techniques can be subdivided into two general categories. One is a linear equalization and second is a non-linear equalization. One is a linear equalization and second one is a non-linear equation. The output of the decision maker is not used in the feedback path, that is adapt the equalizer. Okay, here linear equation there is no feedback. Okay, we are not using the any feedback path. Okay, we are not using any feedback path. Coming to non-linear equation, we can use the feedback path. No need of feedback path. Here we need the feedback path. Okay, that is in the equalization. The output of the decision maker, it is used to feedback. That will also you can see in the next slides. Then you can understand clearly what is a linear equation, what is a non-linear equation. Many filter structures are used to implement the linear and also non-linear equation. We are having the different types of filter structures. One is the FR filter structure and second one is the IARE filter structure. That is a finite impulse response structure, and second one is the infinite impulse response structure. With the use of these two filter structures, we can implement the linear and also non-linear equation. And also we are having the different types of algorithm in the equalization techniques. Okay, that will also we'll see in the next slide. You can see here what is the equalizer. It compensates the equalization, it compensates the intersymbol interference. Here we are having the two types of equalization. One is a linear and second one is a non-linear. One is a linear and second one is a non-linear. Okay, coming to linear means here there is no feedback path. In the linear section, no feedback path. Coming to non-linear, need the feedback path. Okay, that is the main difference between the linear and also non-linear. Coming to linear, we having the two types of structures. One is a linear transversal structure, and second one is a linear lattice structure. Okay, the equalization having the two types of equalizers. One is a linear and second one is a non-linear. Coming to linear, we are having the two types of structure. One is a linear transversal structure and second one is a linear lattice structure. Coming to non-linear, here again divided into three types of non-linear equalization. One is a decision feedback equalization. Next one is a maximum likelihood symbol detector. Next one is a maximum likelihood sequence estimation. Okay, this is a three types of non-linear. Again, these three types again divided into different structures. One is a transversal structure, lattice structure, transversal channel estimation. Okay, here we are having the two types of equalization. One is a linear equalization, second is a non-linear equalization. Coming to what are the different structures of the linear? One is a transversal and second one is a lattice. Coming to non-linear, here we are having the three types of the non-linear equalizers. One is a decision feedback equalization, maximum likelihood symbol detector. Next one is a maximum likelihood sequence estimation. Okay, again divide into three different structures. One is a transversal, lattice, and also transversal channel estimation. Okay, these are the types and also structures of the equalizers. And next, coming to algorithms. Okay, in that we are using the equalization algorithm. Okay, what are the equalization algorithm? Where we are using this equalization algorithm means in the training session and also tracking stage, we are using the adaptive equalizer. This equalizer having the algorithms. With the help of algorithm, we can separate the tracks. Coming to algorithms for the linear equalization, one is a zero forcing algorithm. Next one is a LMS algorithm. That is a RLS and a fast RLS. Square root RLS for the linear and also linear equalization. Coming to lattice, only we are using the gradient RLS. Actually, here LMS is a linear mean square error, and second one is a recurrent linear square, and a fast RLS and a gradient RLS. Coming to here, also same algorithms repeated into the nonlinear equalization. Same thing, transversal coming to LMS, RLS, fast RLS, square root RLS. Coming to lattice, we are having the gradient RLS. Coming to transversal channel estimation, we can use the LMS algorithm, RLS algorithm, fast RLS algorithm, square root RLS algorithm. Okay, these are the classification of the equalizers. Okay, what is the equalization? It compensates the particular intersymbol interference signal. And also we have the two types of equalization. One is a linear equalization and second one is a non-linear equation. What is the difference between linear and also non-linear equalization? The first one is a linear equalization means there is no feedback in the output section. There is no feedback in the output section, that is from the decision maker. Coming to non-linear, in the output section we need the feedback path from the decision maker. And also two types of the structures in the linear equalization. One is a transversal and second one is a lattice. Okay, coming to non-linear, again divided into three types of non-linear equalization. One is a decision feedback equalization, maximum likelihood symbol detector, and third one is a maximum likelihood sequence estimation. Okay, these are the different types of the non-linear equation. And also we are having the structures, transversal and also lattice structures for the linear. Same as the non-linear, also transversal, lattice, transversal channel estimation having for the non-linear equation. Okay, different types of algorithm, zero forcing, LMS, RLS, fast RLS, square root RLS for the both linear and also non-linear equalization. This is a classification of equalizer. Okay, here you can see this is the equalization mainly. Here we can go with the some training stage and also tracking stage. Coming to first stage is the training stage. With the help of these message signal, it can passes to the modulator. transmitter, radio channel, RF radio frequency front end, and also immediate frequency stage, and finally we get the detector match filter. Here we have some coefficients. Okay, what are the coefficient given to the y of t, and also we can add in the some noise to the y of t. Then the both y of t equal to, we can write y of t equal to x of t into f of t plus nb of t. Okay, this is the sum y of t. Then we here y of t we can given to the h equivalent, that is the adaptive equalizer. Here we can using the algorithms, whatever algorithms we are having, we discussed just now, or we can go the sometime zero forcing algorithm, LMS algorithm, RLS algorithm. Okay, here this algorithm it happening the separating the tracks. Okay, then that given to the decision maker. Here the decision maker again given to the any errors, it given as a d of t. Okay, like that we can go with the communication system in the adaptive equalizer. This is the two stages. One is training and also tracking stage. Okay, mainly we having the three types of techniques. One is equalization, one is diversity, one is channel coding. Okay, the major we are having these three types of techniques. With the help of these three types of techniques, we can improve the link performance of the particular radio communication channel. Okay, first one is why we go for this techniques means in the mobile radio propagation we're having the some multipath fading and also interference, that is nothing but a co-channel interference or addition channel interference. But we're having the propagation we can overcome by the these equalization, diversity and also channel coding. And we have the another one without equalization, diversity and channel coding also we can improve the signal performance, that is increasing the transmitted power. Increasing the transmitted power also we can improve the signal performance, but without increasing the transmitted power we can go with the equalization, diversity and also channel coding. Okay, mainly sometimes you can go using one is the equalization, sometimes we can independently go with the diversity, sometimes we can go with the channel coding, but sometimes we can combine these three techniques for the improving the link performance. Okay, the first one, equalization, it is mainly it compensates the intersymbol interference, and diversity it compensating the channel fading, and also channel coding is the detects the and corrects the errors. But we can in this one we can adding the some redundant bits. In the channel coding we can adding the some redundant bits that is compensating the link performance. Okay, coming to equalization, we having the fundamentals of equalization, survey of equalization. There we are using the linear and also non-linear equalization. That is the types of equalization. There mainly we can use the different types of algorithms. Coming to diversity, here we can whenever using diverse technique, we are having the different types of diversity techniques. One is antenna polarization diversity, frequency diversity and also time diversity. With the help of these diversity techniques, we can improve the signal performance without increasing the transmitted power or bandwidth. Okay, here and also one more is the channel coding. Here we can adding the redundant bits into the transmitted signal. There we can use the black codes and also convolution codes. Okay, with the help of this one we can increase the channel performance, equalization, diversity and also channel coding. First one is fundamentals of equalization. How it is causes the intersymbol interference means by the multipath propagation and also any errors in the bit errors in the receiver, and also whenever transmitted from the signal to transmitter to receiver, in between we are having the some obstacles, different types of obstacles are nothing but with the propagation mechanisms. Whenever it is a transmission occur, that is some intersymbol interference will be there. Okay, we can overcome by the intersymbol interference by the equalization. For that we are having the two types of stages. One is a training stage and second is a tracking stage. Okay, this is the two stages of the particular communication system with the help of adaptive equalizer. Okay, these are the different classification of the equalizer. Here we can using the two types of equalizers. One is a linear and second is a non-linear. And type structures in the linear equalization, one is a transversal and second one is a lattice. Coming to non-linear, we are having the different types of non-linear equalizations. One is a DFE That is a decision feedback equalization. Second is a maximum likelihood symbol detector. Third one is a maximum likelihood sequence estimation. These are the different non-linear equation. Same as linear structures, we're having that transversal structure and also lattice structure. But coming to non-linear, three types of non-linear structures. One is a transversal, lattice, and a transversal channel estimation. Okay, we have both. We're having the different types of algorithms. One is a zero forcing algorithm, LMS algorithm, RLS algorithm, fast recurrent linear square algorithm, square root recurrent linear square algorithm, and also we can use sometimes gradient recurrent algorithm. All are we can using into the first stage and second stage of the equation. Okay, in the next session we discuss what are the different types of algorithms, how it is compensate the intersymbol interference. We'll discuss in the next session, and also we discuss the diversity. What are the different types of diversity? Also, what are the diversity algorithms? And the next, and also we can go with the channel coding in the next session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.